morning, everyone, and welcome to the Fiber Broadband Association's Fiber for Breakfast. We're now on our 27th episode of 2026, so we have officially entered the second half of 2026. In Washington this week, both the House and Senate are in recess, but we'll be hitting the hill in full force next week, beginning with our board retreat on Tuesday. Then we have our Fiber Broadband Association's DC fly-in on Wednesday, July 15th, followed by FBA's Fiber Day on the Hill on Thursday, July 16th. For Fiber Day on the Hill, we'll be back in the Rayburn building on Capitol Hill and expect to meet with about 200 plus members of Congress and their staff and members of the administration and key agencies such as the FCC, NTIA, USDA, to name a few. So hopefully you can join us for that. And then the Fiber Broadband Association will be back on the road at our Regional Fiber Connect workshop to be held in Bozeman, Montana on Tuesday, July 21st. I'm looking forward to a little cool weather in Bozeman. Registration for Bozeman continues to be extremely strong, so please register as soon as possible. And you can do that on FBA's website. After Bozeman, we'll be heading out to Omaha in August, Boston in September, Savannah, where I am now, in October, Vancouver, British Columbia in November, and then we'll finish out the year with our premier members meeting in Islamorada, Florida in December. Last week on Fiber for Breakfast, our guest was Dr. Prem Kumar, Professor of Information Technology at Northwestern University, who discussed the quantum edge, why fiber providers should pay attention now. You know, this was a really popular episode of Fiber for Breakfast because I think a lot of people in the fiber business share my interest in quantum physics. Dr. Kumar shared that he and his team at Northwestern have demonstrated that quantum signals can coexist alongside high-capacity classical broadband traffic on the same fiber. Their experiments have demonstrated quantum entanglement over 25 kilometers of fiber while also carrying classical timing and communication signals. And his team also demonstrated quantum teleportation, beam me down, Scotty kind of stuff, over 30 kilometers of fiber with classical broadband traffic. So it's really exciting, and quantum network is here. So in short, fiber broadband networks will be essential for the future of quantum networking. If you missed that last week's episode, you can go to our website and watch replay. Today on Fiber for Breakfast, our guest is Ahmed Ali, the senior analyst and lead of CRU's Optical Fiber and Cable Service, discuss optical fiber and cable market outlooks, the role of holocore and multicore fiber. Ahmed is the senior analyst and lead at CRU's Optical Fiber and Cable Service. He covers global optical fiber and cable market trends with focus on demand, supply, pricing, technology development, and regional market dynamics. His current research includes data center, fiber demand, fiber to the home rollout, next generation fiber technologies, and fiber supply chain developments. So welcome, Ahmed. Hope you're staying cool in London. And for our audience, please type your questions as go, and we'll work those into discussion. So with that, I will turn things over to Ahmed.
Right. Thanks a lot, Gary. Good morning, everyone. Good afternoon. Thanks for joining us. And I guess a quick intro about CRU. If you're not familiar with CRU, we are a global market intelligence firm. We've been around for about 55 years, focusing on different industrial markets, including wire and cable. And optical fiber and cable has been a core part of this coverage for almost 30 years now. And we've built a global team of research analysts across different regions. So we're tracking the market very closely, and I guess that's kind of where I'm starting with. If you look at the optical fiber market or optical cable market over the last 3 decades, it has been a kind of growing in cycles or waves, if you may, related to different technologies shifts and different emerging applications from 3G to 4G to 5G, and also the development of FTTX from FTTC to FTTH and beyond that. Now we see, of course, FTTR, fiber to the room. So with every new technology, demand for fiber increases. And as you can see here, we are right now in the middle of a new phase of growth that's mostly been driven by the recent expansion of FTTH, the last few 10% in many countries, and also the AI data centers and hyperscale data centers in general, which are becoming more and more the biggest driver for growth. If we look at how's that translating to the demand right now across regions, because it's not even. North America seems to be the highest growth right now. Of course, that's driven by the data center applications, the telecoms applications as well. The FTTH is still expanding in the US. And we see, of course, the demand coming from BEAD, even though it's not as big as the data center. But generally, the US market is the hottest growth area right now compared to the other regions where there is growth. But it might have softened a little this year compared to previous years, just because the higher fiber prices that we're experiencing right now and the shortages that's impacting the telecoms market mainly. So all in all, we're expecting the market globally to grow by 8% this year, and that will still continue to be driven by the data centers. And to kind of look closely at this sector, which is data center versus the telecoms sector, we see that the telecoms, or the combination of telecoms applications like the FTTX and the backhaul, they still make the majority of the demand, and will continue to make that demand over the next 5 years or so. But the speed of growth for the data center application is considerable. So we're looking at 16% CAGR in the next 5 years for data centers demand specifically. So that's significant. And if we look at the within that demand, how that breaks down between different applications, you can see here that this is mainly driven by AI workload. Right now, it's both AI and the AI workload and data center interconnect. Over time, of course, the traffic from AI is a major driver. But all in all, whether it's server room application or interconnect, right now, the need for more fiber is driving this AI build out. And I think also comparing the different regions, because like I said, this is kind of concentrated in the US. You can see here how this grows between, grows in the US versus the rest of the world. In 2025, this kind of jumped considerably in the US, and will continue to lead over the rest of the regions. So that's where the demand is. That's where everyone right now is trying to kind of position themselves in that market. But of course, this appetite for fiber from the data center applications, the increased use of fiber in optical cables, so that continue to increase as we build new data centers, but also within the data center themselves, they use more fiber. So the standard fiber is reaching its limits at this point in terms of latency. We see AI demanding ultra low latency more and more, and especially when we use this distributed kind of topology to build AI factories, you need to have very high speed connections between them. The signal quality itself the standard fiber is at limits in terms of the nonlinear effects and the distortion, and AI needs a improved performance in terms of the signal quality. And of course, the capacity limitation as well, because now we're kind of using more fiber, high dense cables, high count fiber cables within the data centers, also in the interconnect. And all of that is kind of confined into a limited space. So over time, we're expecting this is going to cause an issue in terms of the volume and the weight of these cables being extended in very narrow spaces within the existing infrastructure. And that's where the Holocore and Multicore comes into the picture, because they are being developed as solutions to these problems. So Holocore, of course, the main benefit of Holocore is replacing the solid core in the standard fiber with air. So of course, light travel faster in air, so that results in faster signaling and lower latency, and it preserves the signal quality, of course. So all of that adds into can translate into longer interconnect distances or faster traffic between connections. Again, it lends itself perfectly to the challenges that we're experiencing now with data centers in terms of their locations, in terms of how they connect to each other, as the AI clusters start to spread across different locations. So in theory, that's of course very interesting and very appealing for hyperscalers for the AI market. However, it's a new technology. There are challenges in terms of the technology itself, but also the commercial case. On one side, we have the manufacturing process being very difficult. At this point, the yield is very low. It's less than 10% compared to the standard fiber. There are issues, of course, with splicing and how you deal and handle how you deal with this type of fiber if you want to cable it or if you want to install it. All of that, all of these issues are kind of combined together to make it very challenging to deal with and to install. And also the cost, because it's still very, very high in terms of cost compared to standard fiber. We're talking about more than 3,000 per fiber kilometer. So that makes it very niche application and very specific to certain problems, and also to certain types of buyers, because not all of the current fiber buyers or cable buyers are willing to or able to spend that much on fiber. Moving on to the other solution, which is solve a different issue, which is the capacity. So Multicore is not necessarily a new innovation in terms of it doesn't improve the signal like the Holocore, but it's it allows the fiber strand to accommodate multiple channels. So that means you can have higher bandwidth within the same fiber. And that, of course, leads to using, well, in terms of space, that's less space, and in terms of weight, that less weight, of course. So lends itself perfectly to the server room scenario, where you have dense cabling and very high count fiber connecting the different servers. Now you can actually replace that with Multicore. So again, in theory, that sounds also very good, but similar to the Holocore, it's a very challenging technology in terms of how you produce it. Relatively, it's easier than Holocore if you look at it from a manufacturing process, but also compared to standard fiber, it's still not straightforward. So it's a kind of work in progress for this technology. The cost is also high. So kind of similar challenges to Multicore in terms of cost, in terms of manufacturing, in terms of the ecosystem as well, because we're still trying to understand how the connectors and how the splicing and the transceivers and all of these components needs to develop as well to allow these technologies to be deployed very efficiently. So just to kind of summarize where we are with these technologies right now, I did mention that the manufacturing process is challenging, and that is hopefully will resolve once we get to some standards. Unfortunately, that's still not happening yet. However, we see with the Multicore, the market is starting to align itself around certain types of design. So earlier this year, Corning, AFL, and Sumitomo, along with TerraHub, managed to decide to agree on a multi-source agreement type of deal where they would prefer to work on a 4-core design. So at least this is a step in that direction where the market is starting to recognize where we are with Multicore and where we're headed. So Holocore is still not there, but we're expecting Multicore to accelerate first in terms of standard and in terms of the manufacturing process as well. As I mentioned, cost is still really high. That will drop as the manufacturing process becomes more efficient. I guess the expected timeline, we are going to look at the model that we developed in terms of how the volume is growing, but we are looking at the next 3 to 4 years for these technologies to reach a point where there is some sizable deployment. So it's still relatively early days. The ecosystem is also interesting because we see lots of the big players right now aligning themselves and their strategies around these technologies. In China, the big four, YFC, Fiber Home, ZTT, and Hongtong, have committed to developing Holocore. In the Western camp, we have Corning, Prysmian, of course, with Microsoft. Corning and Horizon with Microsoft, but Prysmian with Relativity as well. So there are these collaborations happening. Multicore has a bigger ecosystem. So in addition to these players, we also have the Japanese and the Indian players also being interested in developing this technology. So I'll just share our kind of understanding or our forecast in terms of how these technologies are going to evolve over time. As you see, over the next 5 years or 4 years now, up to 2030, is still relatively a small amount of volume that will be available. As I mentioned, that's due to the difficulty and the complexity of producing these, not necessarily because of the demand is not there, but because we still can't produce them or can't scale them efficiently. Multicore might scale faster just because it's easier to manufacture Multicore compared to Holocore, and it's been around a little bit longer. So we're expecting around 0.8 million fiber kilometer in Holocore and 2.7 million fiber kilometer for Multicore. That will accelerate after 2030, given that the AI data center boom continues and we see more advanced development and design in the data centers themselves that will incorporate more and more of these technologies. And finally, I think I just want to highlight the use cases. So this growth will not be even across use cases. Of course, it is linked to the data centers very closely, but it kind of varies between the two. Holocore, because it's dedicated to low latency, ultra low latency, it fits within the DCI space, and we see that developing very closely in that for that use case. Other use cases like telecom backhaul and server room application, and also even for quantum computing and the financial sectors. All of these are use cases that are being discussed. The financial use case is actually happening. It's not a future use case, but they are smaller in terms of volume, and we expect these to take off once the use cases has been proven for the DCI. For Multicore, it's different, and it's quite interesting because I did mention that manufacturing it might be a little bit easier, but the business case for Multicore is still developing. It's not as clear as it's for Holocore. And for DCI, of course, we're looking at shorter distances. It's not designed for our distances. But we're also, of course, subsea applications. It's already using 2-core. So we're expecting 4-core to take off there as well over time. So it's a little bit more diverse in that regard. And of course, like I said, the use case for Multicore is still developing, and we'll track that, and we will update our model as we see other evidence that other use cases are evolving. So I think that's basically kind of the forecast that we have developed for these two technologies. They are very interesting technologies, and we see them developing in the background. Holocore has been the hot kind of topic last year. This year it's Multicore. So both of them are gaining traction, and we expect them to continue gaining that traction over this year and next year, driven, of course, by this insane growth in the AI and data center sector. Yeah, thank you. I guess for this opportunity, Gary, to share our thoughts, and of course, if there are any questions, happy to answer them right now or even after the session. Feel free to reach out. Over to you, Gary.
Ahmed, a lot of super interesting stuff. First of all, can you help clarify? So when you think about single mode fiber, it's up and to the right, and this is more incremental. When you think of like Holocore and Multicore, very, as you would say, niche, application specific, where latency is king or the size of the cables is very important.
Yeah, I think Holocore and Multicore are not meant to replace standard single mode or solid core. Given the high cost that they are right now, there are going to be premium applications for very specific type of challenges. So of course, Holocore, when you want that ultra low latency, which makes sense for AI application, but also I assume there will be some certain sectors within the enterprise market, like the financial sector. It could be the healthcare sector at some point, where you need that ultra low latency to connect two sites. And that's possibly where the telcos might be able to deliver some services. So there will be some niche applications where you would go to your system provider, whether it's hyperscaler or a telco or dark fiber, and build that specifically for that use case. And that's how they kind of will coexist. So I don't expect Holocore or Multicore to take over, but they will have their space in terms of the kind of the challenges that they solve, and of course the revenue, given that they are very high value. These high value application requires high value types of fiber.
Yeah, absolutely. So really not a fiber to the home play, but more of a data center or enterprise where you have to manage a lot of cables, or, when you look at the costs, when GPUs and latency, you want to connect GPU racks with ultra low latency. So some manageable.
Of course, it has to make
application.
It has to make sense in terms of like how much gain you will get when you deploy that.
Yeah. And there's a great question that kind of what we talked about before we jumped on, but how does co-packaged optics or near packaged optics impact your expectations, and what is currently incorporated into your expectations?
So we are kind of taking a closer look at these in terms of the transition from copper to fiber, because we do cover the two markets, and in our kind of in our copper demand for data centers, we see there is a clear transition. The demand is declining, and that's where the co-packaged optics fits in, because more and more fiber is of course right now takes a big portion of the DCI, the connections between server rooms and all of that is being connected by fiber. But the last leg, which is the scale up level, these connections between the GPUs, where up until now copper has been kind of cost efficient. There's no demand, I guess, in terms of the latency and in terms of the performance. Copper has been good for the normal cloud workload, but now for AI, you need to overcome that minimum kind of signal distortion and delay that copper will introduce, and there is a need to move further closer.
So in short, the details matter as we get into AI and quantum, and so we'll start seeing more co-packaged. Let's jump into this. Is a really good question, and I really haven't spent a whole lot of time thinking about this, which I should. Do hollow core and multi-core require additional bend radius, and will this impact fiber closures, fiber splice trays, handhole sizes? So, that's, I don't know if you've looked at that at all in your meetings with manufacturers.
I guess what I would say that the entire kind of value chain will need to adapt to these new technologies. So I guess in terms of connectors, in terms of the laser used, in terms of the splicing and all of that, you will need to, especially for hollow core, you will need new equipments and new kind of ecosystem around that. Multicore is a little bit more adaptable. So part of the appeal for multicore is that you can reuse what the existing standard single mode equipment, whether it's the machinery to draw the fiber or the kind of the splice of the testing machineries and all of that. So I would assume for multicore there is room to reuse the existing technologies, but none of these has developed a commercial product yet, which is the stage we're in. All of the projects are customized for specific use cases, and until we have that commercial off-the-shelf type of product where all the components of the network are available, I guess we'll continue to kind of customize what we have.
So 2 quick questions because we're out of time, but one is, did you have a price point for cost of multi-core per kilometer?
Yeah, I think for multi-core, we're looking around, we're talking hundreds. It's not in thousands as the hollow core. I would say the kind of what we hear on multi-core is it's more expensive than the equivalent number of cores that you get from individual single core. So 4-core hollow core with multi-core would cost more than just combined individual 4 single mode. So that just gives you an idea.
Yeah, the ductwork, the handling, all that stuff would probably make, so that's going to be, I think, have some economies of scale and efficiencies.
Exactly. And that's why it's not easy to kind of just move from single mode to multi-core, because it wouldn't make sense economically yet.
Well, space will be king. And, when you're looking at these handling these massive, like 6912 cables and things like that. So, to reduce the size. And there's a lot of other good stuff that's reducing size, like reducing the cladding and so forth. Last question. I know that, Corning and Microsoft had done some really good stuff in hollow core, but the question was, how much hollow core has actually been deployed to date?
I think if I go back to it's a very minimal number. I guess hollow core is we're looking at a few projects done by Microsoft. The Chinese telcos, the 3 Chinese telcos, are also working with the top four fiber manufacturers in China to deploy some hollow core, and we're talking about like 10 kilometer or something like that in terms of like a single project. So it's combined that they don't really make a lot of volume right now. I wouldn't have the number on top of my head right now. I guess it's in the forecast in 2025, closer to that's what we estimate for 2025.
Yeah, 26, but yeah, we got a long ways to go, but it's pretty exciting on what the potential of both multi-core and hollow core. Ahmed, thank you so much for sharing. You guys always have great research. I appreciate you sharing it. It's also nice to see how the U.S. stacks up against the rest of the world, and pretty exciting about the opportunity. What I'm calling it's a super cycle, investment cycle now, going from fiber to the home to AI infrastructure. So exciting time. And hope everybody can join us next Wednesday. Our guest is Colin Riley, the Vice President of Data Strategy and Technology Service at Connected Nation. He's going to discuss closing broadband gaps with smarter grant oversight. So you're not going to want to miss that. Again, thanks, Ahmed, and we'll see you guys. Hopefully, we'll see you guys in DC next week. It's going to be pretty fun.